The most advanced fighter jets on Earth are supposed to be replacing the Lockheed Martin F-22 Raptor. China has a J-20. Russia built the Su-57. America already flies a newer F-35. And now sixth-generation fighters are already on the horizon. But despite all of that, there is still one problem no rival jet has fully solved. None of them can do what the F-22 does in the sky, not at its altitude, not at its speed, and definitely not while staying nearly invisible to radar. This is a fighter jet that can perform maneuvers so extreme they almost look impossible. A stealth aircraft capable of turning harder, climbing faster, and controlling the fight in ways most pilots never experience. And here's what makes the Raptor truly terrifying. The F-22 wasn't built just to compete with other fighters. It was built to make sure they never had a chance in the first place. So how did the F-22 become the untouchable king of air dominance, and why has no other jet truly matched it? To understand why the Lockheed Martin F-22 Raptor still feels untouchable today, you first have to understand what it was actually built to do. Most modern fighter jets are designed as multi-role aircraft. They carry out airstrikes, reconnaissance missions, electronic warfare, and ground support operations all at once. Flexibility became the priority. The F-22 followed a completely different philosophy. It was designed for one mission above everything else: absolute air dominance. During the final years of the Cold War, the United States began preparing for a future where enemy fighters and missile systems would become dramatically more advanced. Military planners wanted an aircraft that could enter hostile airspace first, eliminate enemy aircraft before being detected, and completely control the skies for every aircraft operating behind it. That goal produced something radically different from traditional fighters. The F-22 combined stealth, extreme speed, super cruise capability, advanced sensors, and super maneuverability into a single platform. Individually, those capabilities already existed in different aircraft, but combining all of them together at this level was something no fighter had ever truly achieved before. And that's what makes the Raptor so unique. Most aircraft are forced to compromise somewhere: speed, stealth, agility, or payload. The F-22 was engineered specifically to avoid those compromises. And nowhere is that more obvious than the way this aircraft moves through the sky. This is where the Lockheed Martin F-22 Raptor stops looking like a normal fighter jet and starts looking almost unnatural. At air shows and training exercises, the Raptor has repeatedly demonstrated maneuvers that seem to ignore the normal limits of high-speed flight. Sudden nose-up climbs, violent direction changes, tight high-angle turns that appear almost impossible for an aircraft of its size. And the reason comes down to one critical technology: thrust vectoring. Most fighter jets rely entirely on aerodynamic control surfaces like rudders, elevators, and ailerons to maneuver through the air. But the F-22 adds something few operational fighters possess at this level: two-dimensional thrust vectoring nozzles mounted on its engines. These nozzles can physically redirect the engine exhaust during flight, allowing the aircraft to change direction even when traditional aerodynamic surfaces become less effective. In simple terms, the engines themselves help steer the aircraft. That gives the Raptor extraordinary control during high angle of attack maneuvers, where the nose of the aircraft points far above the direction it's actually traveling. In these situations, many fighters begin losing stability or energy. The F-22 remains remarkably controllable. This is what allows the aircraft to perform famous post-stall maneuvers like the Hertz maneuver, often called the J-turn, where the jet rapidly pivots in the air to reverse direction far faster than most conventional fighters could ever manage. And unlike some aircraft that sacrifice speed to perform extreme maneuvers, the F-22 can recover energy incredibly quickly thanks to its powerful engines and aerodynamic design. But here's the most important part. The Raptor didn't just become highly maneuverable by accident. It was intentionally engineered to dominate both long-range combat and close-range dogfights at the same time. The aircraft wasn't built under the assumption that one style of combat would dominate forever. Instead, it was engineered to maintain superiority across multiple stages of an engagement. At long range, the Raptor uses stealth sensors and speed to detect and engage threats early. But if an enemy aircraft survives long enough to close the distance, the F-22 transitions into something entirely different, a highly agile air superiority fighter capable of aggressive post-stall maneuvering and rapid energy recovery. And this dual capability creates a major problem for rival aircraft. Many modern fighters are optimized heavily toward one form of combat. Some focus on stealth and missile engagements. Others emphasize multi-role flexibility or electronic warfare integration. The F-22 was designed to remain lethal even after the battle changes unexpectedly. That flexibility matters more than ever in modern warfare, where pilots may face rapidly shifting combat environments against highly advanced opponents. Because in the end, the most dangerous fighter isn't always the one built for a single perfect scenario. It's the one that remains dominant after the fight stops going according to plan. For all of its dominance, the Lockheed Martin F-22 Raptor now faces a strange reality. The aircraft many experts still consider the world's premier air superiority fighter is also slowly approaching the end of its operational life. And that creates one of the biggest contradictions in modern military aviation. Because despite the arrival of newer fighters and next-generation technologies, the United States still does not have a true one-for-one replacement for the F-22. Part of the reason goes back to production. Only 187 Raptors were ever built, and fewer than that remain operational today. The production line closed in 2012 after years of political debate, budget concerns, and shifting military priorities. At the time, many defense officials believed future wars will rely more heavily on drones, precision strikes, and multi-role aircraft like the F-35. But over time, the strategic environment began changing again. China rapidly expanded its military aviation programs. Advanced stealth fighters, long-range missiles, electronic warfare systems, and sophisticated air defense networks started reshaping the balance of power in the Pacific. And suddenly, the United States found itself relying heavily on an aircraft it had already stopped producing. That's part of the reason the F-22 continues receiving major upgrades even decades after its first flight. The Air Force understands something important. Replacing the Raptor is far more difficult than replacing a normal fighter jet, because the F-22 isn't just another stealth aircraft. It occupies a very specific role that few aircraft in history were ever designed to perform: total air dominance against highly advanced opponents. Now, the United States is preparing for the future through the development of sixth-generation programs like NGAD, the Next Generation Air Dominance Initiative. These future aircraft are expected to introduce entirely new technologies involving advanced sensors, artificial intelligence integration, drone coordination, and even more sophisticated stealth systems. But there's a reason the F-22 still remains central to America's air superiority strategy, even as those programs move forward. The Raptor still works. And perhaps more importantly, no rival fighter has clearly proven it can consistently outperform the F-22 across the full spectrum of aerial combat. That's what makes the aircraft's future so fascinating. The king of air dominance may eventually retire, but even after decades of technological advancement, the throne still hasn't truly been taken. The history of fighter aviation is filled with aircraft that change warfare for a moment, but very few change the entire standard by which future fighters will be judged. The Lockheed Martin F-22 Raptor did exactly that. Even today, nearly every advanced fighter program in the world is still measured against the same question: can it match the Raptor? And that says everything, because the F-22 was never just another stealth aircraft. It wasn't built only for long-range missile combat. It wasn't designed purely around electronics or strike missions. It was engineered to dominate the entire battle space from the moment it entered the fight. Stealth allowed it to approach unseen. Super Cruise allowed it to move faster without sacrificing fuel efficiency. Thrust vectoring gave it extraordinary control in close-range combat. And advanced sensors allowed pilots to detect threats before most enemies even realized they were being tracked. Individually, those capabilities are impressive. Together, they created one of the most complete air superiority fighters ever built. And that's why the F-22 still occupies such a unique place in military aviation. Other fighters may challenge certain parts of its dominance. Some aircraft are newer, some are cheaper, some may eventually surpass the Raptor in specific categories. But no fighter has fully replaced the balance the F-22 F-22 achieved between stealth, speed, agility, and control. That balance is what turned the Raptor into more than just another aircraft. It became the benchmark. And until another fighter proves it can truly outperform the F-22 in every environment that matters, the Raptor's reputation as the king of air dominance will remain very difficult to challenge. And that created a problem for every other stealth fighter that came after it, because matching the F-22's agility turned out to be far more difficult than anyone expected. For years, multiple countries have tried to build fighters capable of competing with the Lockheed Martin F-22 Raptor. Some focused heavily on stealth. Others prioritize electronics, long-range missiles, or multi-role flexibility. But even now, no aircraft has fully replicated the exact balance the F-22 achieved. And the reason comes down to compromise. Take the Lockheed Martin F-35 Lightning II, for example. The F-35 is one of the most advanced fighters ever built, but it was designed with a completely different mission philosophy. Instead of pure air dominance, the aircraft was built as a multi-role platform capable of performing air combat, ground attack, reconnaissance, and electronic warfare missions across multiple military branches. That flexibility came with trade-offs. The F-35 emphasizes battlefield awareness and networked warfare over extreme maneuverability. It is highly capable in combat, but it was never intended to outperform the F-22 in raw aerial agility. Then there's the Sukhoi Su-57. Russia heavily emphasized maneuverability and thrust vectoring performance in the Su-57's design, creating an aircraft capable of impressive aerobatic displays. But many analysts believe the aircraft sacrifices some stealth performance compared to Western fifth-generation fighters in order to maintain that agility. China's Chengdu J-20 followed yet another direction. The J-20 appears optimized for long-range interception and missile engagements rather than close-range maneuverability. Its larger size and design priorities suggest a stronger focus on range, sensors, and long-distance combat operations. And that's what makes the F-22 so unusual. Most modern fighters specialize somewhere. Some prioritize stealth, some prioritize sensors, some prioritize maneuverability. The Raptor somehow maintained all three at an elite level simultaneously. Even decades after its introduction, rival aircraft still tend to outperform the F-22 in one category, while falling behind in another. And that's why the Raptor continues to occupy such a unique position in modern air combat. Because the closer engineers came to building the perfect stealth fighter, the more difficult the F-22 became to truly replace. This is a reason the Lockheed Martin F-22 Raptor still dominates conversations about air superiority decades after it first entered service. Not because it was the fastest fighter ever built, not because it carried the most weapons, and not because it had the newest technology, but because it achieved something aviation engineers had struggled with for years. The F-22 managed to combine stealth and extreme agility in the same aircraft without heavily sacrificing either one. And that was incredibly difficult to pull off. Stealth aircraft are usually designed around one primary goal: minimizing radar detection. To achieve that, engineers carefully shape the aircraft to scatter radar waves away from enemy receivers. Sharp angles, smooth surfaces, internal weapons bays, and specialized materials all become part of the design. But those same design priorities often work against maneuverability. Highly agile fighters traditionally rely on aerodynamic shapes that generate maximum lift and control during aggressive turns. Large control surfaces, unstable airframes, and specific body geometries can dramatically improve maneuverability, but they also tend to increase radar visibility. In simple terms, stealth and agility usually pull aircraft designers in opposite directions. That's why many stealth fighters prioritize long-range engagements instead of close-range maneuvering. The logic is simple. If your aircraft stays hidden and destroys targets from a distance, extreme dogfighting capability becomes less important. The F-22 rejected that philosophy entirely. American engineers designed the Raptor under the assumption that even stealth aircraft could eventually find themselves in close-range combat situations. If that happened, the F-22 needed to dominate there too. So instead of specializing in only one area, the aircraft was engineered to maintain superiority across multiple forms of combat simultaneously. That's where the Raptor became something truly unusual. It could supercruise at supersonic speed without afterburners. It could remain highly maneuverable at extreme angles of attack. It carried weapons internally to preserve stealth, and it combined all of this with advanced sensors and high-speed data processing. Even today, very few fighters can match that complete package. Some aircraft may rival the F-22 in stealth. Others may rival it in raw maneuverability. But maintaining both at an elite level while preserving speed, stability, and combat effectiveness remains extraordinarily difficult. And that's why, even after all these years, the F-22 still feels different from every fighter built after it. Because it wasn't simply designed to excel in one category. It was designed to control every part of the fight. At this point, some people might ask an obvious question. If modern air combat is dominated by long-range missiles, advanced radar systems, and beyond visual range engagements, does agility even matter anymore? It's a fair question, and one that has shaped fighter aircraft development for years. Modern warfare has changed dramatically from the classic dogfights many people associate with fighter jets. Today, aircraft are designed to detect enemy targets from enormous distances, launch missiles before ever being seen, and destroy threats long before close-range maneuvering even begins. That's one reason stealth became so important in modern aviation. The aircraft that sees first usually gains the advantage. And on paper, that sounds like the end of traditional aerial maneuvering altogether. But reality is far more complicated. Electronic warfare systems can interfere with targeting data. Pilots may lose tracking information. Missiles can miss, be decoyed, or forced off course. And in highly contested airspace involving multiple aircraft, engagements can quickly collapse into chaotic close-range situations where reaction speed and maneuverability suddenly become critical again. That's exactly why the F-22's design philosophy remains so dangerous.